My name is Howard Aileen. I'm a Senior Field Application Engineer for Wind River, and today I will be presenting over-the-air software updates. Here is a typical enterprise network of a medical device manufacturer or end customer that has medical devices that need software updates. An OTA server will be installed in their cloud where it can integrate with their enterprise applications and third-party clouds. They will need access for multiple users and groups with different role-based access controls. Software updates will be uploaded to create campaigns to deploy to these devices. Here is a high-level overview of the OTA server in the cloud. The users will access the portal through a web interface login to manage each of these microservices. The medical devices running Wind River Linux provision the cloud through the secure gateway and report their software versions. The users upload software updates to the repository and create campaigns that direct where the software updates get applied. OSTree Hub and Repo Server is a repository hosting incremental images that can be downloaded. The actualizer agent that runs on the device as a system service periodically checks for updates. Updates are pulled down and installed using OSTree. Binaries are secured with multi-level key pair strategy where signed keys are kept offline and can be rotated. Let's take a moment to talk about the components of the video today. There are three parts. Here's the portal that a user might log into on the OTA server to manage, the various phases of deploying a device, uploading software versions, creating groups, defining what a software update does, and then launching campaigns for that. I also have a video stream here of a device that I'm going to be upgraded so that you can see the console. And I have a terminal window down here that I use to remotely log in through SSH to the device. So let's get started. The first thing we're going to do is we're going to power up the device. We're going to see that it'll boot, and once it's booted, we'll log into it. So now we see that the device is booted. Let's log into it. So we have a remote shell. Now once we're logged in, normally the actualizer agent runs as a service in the background. But in this case, I will run it manually so you can see the log output as it provisions the device. This is the path to actualizer, and we pass to a config directory that configures the device, where it's going to reach out to the cloud, and where it gets its credentials from. So we can see here now that the actualizer read its configuration, got its credentials, reached out to the cloud, and successfully provisioned through the device gateway. And now it has showed up in our cloud for one of our devices that we can do a software update on. So if we go back to the home page, we can see under devices that this device has showed up here. Let's take a moment and look at what occurred in the actualizer agent when it was provisioning the device. We can look at this slide, provides a high-level overview of the actualizer agent running on the device. The agent is responsible for the security keys and provisioning with the cloud. It provides the metadata for the software packages so that we can track which versions are installed on the device and it registers those up in the cloud. It's responsible for downloading incremental updates from OSTree and installing those software updates. Actualizer relies on OSTree installed on the device to perform and manage the update. OSTree manages the contents of the file system very much like a Git repo. It tracks and stores the file revisions on the device. OSTree is an upgrade system for a Linux-based operating system because it performs automatic atomic upgrades of complete file system trees. Next step, let's go back and look at our device here. We can see that the new device has been provisioned on the OTA server, and we can see that when a new device comes up where the device wasn't provided, the name of the device wasn't provided, it'll generate a temporary ID. Let's go ahead and rename the device to something more friendly. Here's the name. Let's rename it. We can also inspect the device and see what its versions are and what's available. So if we look at the device here, since it's a brand new device, it doesn't have any history, it doesn't have any pending software updates, and we can look at the initial version that came with it when it was first provisioned. This gives us a list of all the packages that are available on the device, what their versions are, to track. When it registered with the cloud, when it provisioned with the cloud, it reported where its software versions were at. Next, we can select what software versions that we may want to potentially upgrade the device. If we go in and then look, to save time, I have already previously uploaded several versions of our Windows Linux, a small, standard, which is more full-featured, and then these two here both have desktop graphical user interfaces. One is Sato, and that is what is currently running on the device right now. XFCE is a little more robust desktop, has a little more features, and that is part of the demo. We'll show upgrading that today. If we want to inspect, we can go into it and we can see a little more information about these software releases. It'll give us the version of it that we can also go to the device and confirm that is what's really installed. So if I put this in the background, I should be able to take and do OSTree admin status. And it shows us that yes, that is what we have installed on this device. That is the current version that we have that we're tracking in it. And that is also the version when we were browsing the device before. We were showing all the package and versions, and those correspond to this release that's on the device now. We can also explore the other device releases we have, which is the XFCE. And this is what we're going to be upgrading to. Let's go back to our home. So we've covered provisioning, software versions. The next thing that we need to do is put the device into a group. Software updates are organized by groups. Rather than updating individual devices, it's often better to update a whole class of devices. Create a group that may contain many devices and upgrade that entire group at once. In this case, let's go put our device into a group. I've pre-created a group called NUC Intel x86-64, which is what this board is. And I'm going to have the first instance or first device added to that group. Let's go back to home. Next, we're going to talk about software update. We need to define what's going to happen during the update. If we look here, I've had several updates that I've run recently, but I'm going to walk through creating a new one for you today. First step is we need to pick a name for the update. And a better description on what's occurring. I like to put a date in my description. And I also need to specify the control unit. In this case, I'm going to specify the build for the root file system and kernel from Windows Linux, which is Intel x86 based on glibc standard build plus the Sato desktop. At this point, we need to choose what we're going to be upgrading from one version to the next. This is where you can explicitly state what the version is that it should be having on the device before the upgrade occurs, and then what version it's going to go to. So in this case, we're going to go from SATO to an XFC desktop. If we wanted to force an update, we could check this box and it would upgrade the device to this version regardless. But in this case, I would like to match. I would like it to confirm before it does the update that truly this is the version that we also confirmed already is on the device as a double check. Let's save it. So now we have defined a new software update. Let's go back to home and let's work on a campaign. Let's create a new campaign. First thing we're going to do is select the name. We also select which device group we're coming from. We're also going to select the software update itself. In this case is where we choose whether we want to request the end user's consent or not. In this case, we do not need that. Finally, here's a summary of the software updates going to occur. We can launch it. We'll wait here a little bit for the software update to begin. Here are the updates coming. So in the interest of time, I fast forwarded. We can see that it downloads all the updates before it actually attempts to apply the update. You can see that this is the one that's running. Then it applies the updates, installing with the OSTree package manager. And once it's complete, it reboots the device. Notice that there's two entries. One is the rollback, so that if conveniently we can get to the rollback from the boot menu if we want. You can also roll back from within the device through the OSTree admin shell. So now we see that we have a new desktop. Let's log into it. It's the first time, so we're going to configure it, default config. This is a much more friendlier type user interface desktop. It has a lot more features, terminal windows, cascading windows, a file browser. So it's much more functionality. Now to accomplish that update, quite a bit happened. That was no small upgrade, all managed by Actualizer, pulling down the incremental update from the cloud and using OSTree to apply that update. We can also now log back into the device and confirm what versions it's at now. We notice that this is the new version that we downloaded. We saw that in our software versions for the XFCE, and we see that this is the older version that was there, and it's labeled as rollback. So it's available for us to go back to in case something failed. At this point, we could have written some kind of diagnostic routines that would checked out if the upgrade is proper, ran the application, made sure it could complete and pass all its diagnostics, and then we could declare that this upgrade was good. Otherwise, the device on its own could see if anything failed, device on its own could decide to roll back to the previous version. We can also confirm this in the portal. We can see that we were successfully able to do this upgrade. It was successful, and we can also go over to the device and look at the device itself. Now, right now it's showing it's pending. That is because I need to run the actualizer agent manually. I'm running that manually so that you can see what occurs. So now I'm going to run it on the device. So it comes up and it recognizes that an upgrade has taken place, and that will inform the cloud that that is going on. So we can see here it's checking installation with new OSTree sysroot. It completed the update and reported. So now we can go back over to our device. And we can see that, yes, now we have a history. The device did indeed upgrade. The installation completed. There were no errors. We are at our new version now, and now we are running an XFCE desktop. We can also go to device, and we can check on where it's currently at, what its software is, and inspect what is going on in terms of its properties and the software versions that it's at now. So at this point, we can declare that we had a successful upgrade. But sometimes not all upgrades go correctly. If we look at this slide here, this is the typical continuous delivery flow that a lot of customers use when they're upgrading their devices. In this case, a customer would get a release from Wind River for LTS 18 or 19, which is our long-term support versions. And they would test and integrate and build. They would produce an RPM package feed. As part of the platform projects that come from Wind River, we automatically generate the delivery in terms of packages. So the customer could deploy when they do a new build in their platform project and have new RPMs that have a delta increment, they can gather up those RPMs, put them on a repository, and provide those somehow to the device, either manually or through a network feed. But those are individual packages with individual file sets. And generally, customers feel confident in doing some level of OS update, maybe delivering their application, delivering containers through this type of mechanism, core parts of the operating system, the kernel, many of the device drivers, certainly replacing the entire desktop from one version to the next. That's a heavy lift. And it's not always advised to do something like that without some kind of means of doing a rollback. If we look at this next slide, let's talk about what happened when the actualizer was pulling down the software updates and using OSTree. During a campaign, the incremental update is downloaded and OSTree overlays against the existing file system. Only the delta needs to be downloaded, which makes it fast, and it means there is a minimal update that's needed over the network. And that is very important when maybe perhaps you're upgrading over a cellular network. This also means that the existing files, all of them, are still left on the device to support a rollback. And I think we saw that when I was showing the admin status in OSTree. So what's happening here is the external OSTree repository is providing this update to download. The entire update is downloaded and applied to the file system as an incremental overlay on top of the existing file system. Then the update remains inactive until the next reboot. The update is deterministic as it becomes a single incremental update that can span many files, as opposed to applying individual files through an RPM one at a time. Many files are applied to the operating system in one single atomic operation. Let's actually go back and let's try and witness how this is done, how we would go about doing a rollback. If we simply reboot the device, we can choose which one that we want to use. We can go back to the previous version in the menu. We could have done this programmatically or at the command line within the OS, but we also provide it here on the console because it makes it easy for customers to toggle back and forth between previous versions. So if we reboot this, we're going to see it come up. And we're back to the previous desktop. This all occurred within a single partition. We did not use multiple hard drives. We did not even use multiple partitions within a hard drive. We used a single partition to roll back advantages that OSTree provides. We can log in now, and we can look and see where we're at. So we are back in time now in terms of we've rolled back to the previous version. That is now the current. So if we look at the next slide here, this is what we are now supporting. So continuous deployment with OSTree offers many advantages. Rollback is no longer a challenge when we're using OSTree. Instant rollback and roll forward can be done within the file system partition. No longer is it necessary to maintain a redundant partition on the file system that have limited storage. And for complex devices with user databases, this redundancy wouldn't be practical anyway. Using OSTree means over-the-air software updates can safely upgrade and roll back any part of the file system. This includes the operating system, kernels and drivers, containers, application, and customer data in one single atomic update on reboot. It gets back to what many customers want. The upgrade is an all or nothing, nothing in the middle. The efficiencies in deployment lead to CI/CD or continuous integration and continuous deployment workflows. They speed up the ability to take these releases, integrate and test, push them up to your OSTree repositories in the cloud, apply them to your device, and meet some of the newer guidelines that are taking place in the FDA around timely upgrading of security updates. It also means this type of structure affords nicely to support even the initial manufacturing of the device. So I hope you enjoyed this video. If you have any questions, I provided my email at the beginning of the presentation. Thank you.